Hello, I've had a question in 3 Physics, Unit 5, Lesson 4, we're looking at 35E, one of the circuit analysis questions. So, with all circuit analysis questions, I like to set up my chart. So V, I, and R. And I'm looking, and I have 1, 2, 3, 4, 5, 6 circuits here to take a look at, or parts of the circuit. 1, 2, 3, 4, even 6, and my very final row is my totals. So we'll separate this off. Okay, now I fill in whatever information I can. So I have a total of 150 volts right there. At circuit or at resistor 1, it's 5 ohms. I don't know anything else. Number 2 is 1 ohm. 3 is 15 ohms. 4 is 10 ohms. 5 is 1 ohm. And 6 is, looks like 20 ohms. And I'm looking for any other piece of information. They don't give us anything. Again, I need 2 things in a row, all right, to help me solve the rest of the puzzle here. So what I need to do is I need to take this circuit and I need to crunch it down into a single pathway. So I start with my battery. Quick sketch of the battery, 150 volts. Goes here, goes through resistor 1. It's only one pathway, so that's fine. I don't have to worry about that. But these guys here, I'm going to have to crush into single pathways. Okay, so I'm going to have a circuit looks like this in step 2. All right, so I'm going to have a resistor I'm going to call 2, 3, and I'm going to have a resistor here called 4, 5. No, it's not 5. Try that again. 4, 5. All right. So we know that 1 over resistor 2, 3 is equal to 1 over R2 plus 1 over R3. So solving that, we have 1 over 1 is 1 plus a 15th. So that's going to be 16 over 15. But we need to flip that because we want it to be just R23. So if I do that, I get 15 over 16. And again, I'm going to go 2 decimal places, I guess. So 0.94 ohms. So I now know that that's 0.94 ohms. Now I have to figure out what 4, 5 is. So resistor 4, 5, 1 over R4 plus 1 over R5. And those are 10 and 1. So 1 over 10 plus 1 over 1 is 1. So we get 11 over 10. I flip that fraction, whoops, because I want R4, 5. That gives me 10 over 11. So they're pretty close, 0.91 ohms. All right. Now, I have to get it down to a single pathway, so I'm going to have to go one more step here. So I'm going to give myself another quick little sketch. My final sketch, 150 volts, goes through here. Now we're going to make those guys into 1. That one's a single. So just pulling down some information here. A 5 ohm and a 20 ohm. So here, it's 5 ohms. Here's 20 ohms from above. This circuit here, now it's getting a little crazy. I'm going to not call it 2, 3, 4, 5. Let's call it whatever. Let's call it resistor 2, 5. All right, so we want to find the resistance of the resistors put together, 2, 3, 4, and 5. Now in this picture right here, they are in parallel, so we have to treat them in parallel. So that would mean that 1 over R25 would equal 1 over R23 plus 1 over R45. So 1 over 0.94 plus 1 over 0.91. And we do our division there. So 1 divided by the 0.94 plus bracket 1 divided by 0.91 bracket. So I get 2.16. Now we need to flip it because that's 1 over R25. So we flip it. So 1 divided by that answer, and I get 0.46 ohms. So that means that this one right here is 0.46 ohms. Now we're in series. There is only one pathway to follow, so our total resistance is the 5 ohms from here. Those 4 resistors that were all kind of in parallel crushed down to 0.46, and then the last one is 20, so we get 25.46 ohms. All right, so moving that up to my picture up here, 25.46. We can now find, picking up an accent here, we can now find our total current. So 150 equals I 25.46. So when we do that, 150 divided by the 25.46, I get let's call it 9 amps. So there we go. All right. Now looking at our original picture, at circuits 1 and 6, there's only one pathway, so all the current has to go through that one single pathway. All right, so that means we can find out the voltage at each of these. So we get 29.5 volts to go through the first one, right? Because V equals IR, so we're just multiplying these two numbers together. Similarly, 5.9 times the 20 is 118. All right, so that takes care of these two circuits in total. So we know our voltage here was 29.5. Our voltage here is 118. So what's left? Well, I started with 150. I used up 29.5. I used up 118. All right, an electron can see the whole circuit. They know how much they're going to need. So what is left here? So 150 minus the 29.5 minus the 118. I have 2.5 volts remaining. Okay. Now, when we analyze our picture here, so I'm going to clean this up so I can see it a little bit better. Okay. If you're an electron that gets to this point right here, point A, and I want to get over here to point B, I see that I have 1 way to go, 2 ways to go, 3 ways, and 4 ways. I don't ever have to go through 2 consecutive resistors. Each of these are single pathways, which means that my voltage, if I choose this path, I have to use 2.5 volts. If I choose this path, it's 2.5. This one's 2.5. This one's 2.5. So the voltage for each of those resistors, since it's the only pathway, is 2.5. So there we go. Now we can figure out the rest of it just doing our division. So that would mean that for number 2, 2.5 divided by 1, so 2.5 amps are going to go through circuit 2. 2.5 divided by 15, 0. Let's call it 2. 2.5 divided by 10 is 0.25. Let's call it 0.3 and 2.5. Those all, this current splits 4 ways here. So basically, when you get to point A as an electron, you have 1 option, you have 2 options, you have 3 options, you have 4 options. So the current splits into 4. So that means that if we want to do a bit of a check here, these 4 currents, no, too far with my line, try that again. These 4 currents should add up to our total current. So we know that 2.5 and 2.5 is 5, and then we're adding another 0.5, so it's 5.5, so we're a little low, but I had some rounding in there. So that gives you a general idea on how to analyze that particular circuit. If you have any other questions, let me know. They are tricky. and they do take a little bit of time.